Hi there and welcome to a new video in which we're gonna be talking about abstract classes in Godot, which is a concept that is super related to another one, which is basically inheritance. So imagine that in this 3D game, okay, or in any game that you may have. Well, in this case we have the player and we have a variety of obstacles. We have these spikes over here, we have this other saw over there, and we have those other spikes over there that are rotating around. Now all of these obstacles, they basically make the player directly lose. It doesn't matter with which I collide, all of them have the exact same behavior. But what happens if suddenly, okay, when I collide with the spikes, I want to do something different. Maybe I want to have a life, a health bar over here, and maybe the saw directly kills me, okay, whereas the spikes maybe just decrease 20% of the total health. So how exactly are we gonna be managing this? You may be thinking of lots of solutions in order to do this because, well, this is the obstacle script, and here, well, on body enter, what we're directly doing is calling the game over function. So here we could say, okay, if the name of this node is spike block wide, do something else. If the name is spikes, do something else, and if it is so, do something else. But this is not super expandable, and I'm gonna be explaining you how and why with abstract classes and using inheritance, okay, in Godot, we're gonna be doing a much better system. So first of all, in order to see the true power of this, I have an example which is actually made in Unity, but it doesn't matter. Unity already has all this and even with more functionalities, okay? But it's gonna be super useful for us to understand the true power of this tool. So in this case, it's a pretty simple RPG game in which the player moves around, and as you can see, we have different types of enemies. We have one type of enemy that is a short range enemy that has like a melee weapon, and the other that is like a wizard that shoots a projectile, okay? So they have pretty different behavior, but at the same time they have similar behaviors. They all flip, as you can see, both of them flip, both of them have a health bar, okay? But they of course have differences. This one shoots a projectile, this one attacks with a weapon. So you can see that if you try to do something like this with Godot without using inheritance or abstract classes, okay, at all, it's gonna be quite difficult or even impossible. If you want to take a look at how exactly this is done in Unity, and if you have experience with Unity, you are gonna be able to understand this. Well, how this works is that I have a base enemy prefab, okay, and then I have two prefab variants, okay. One is the shooter enemy, and the other one is the base enemy, okay. So this one is the base, okay, as you can see, this inherits from enemy, which is this one, and any modification I do to the enemy is gonna be applied to all of them. Let's say that I get here the sprite color and I change it to red, so now all of my enemies are completely red. I want to scale in all my enemies, okay, so let's make them, instead of 5, let's make it 50. Now all of my enemies are way bigger, okay, and well, if they haven't been resized, it's because there is an override here or whatever it is. As you can see here, this is overridden, but you understand what I'm talking about. And well, in reality, this enemy, okay, this is the base enemy. Let me go back to the prefabs. This enemy has like lots of scripts attached to it, okay, and then each of these base enemies, they may have different things assigned to them, such as, for example, I don't know, let me look here for a difference. So for example, here the shooter enemy has a light colorizer because there is a light on this element over here, whereas in this one there is no light at all, okay, but they still share lots of things, as we have seen. So you can start to see all the power that abstract classes as well as inheritance has, okay. Because, well, I don't want to dig any deeper into this project in specific because it's quite complex and we're not gonna go that complex, but I wanted to explain you like what exactly you can achieve with this. And once again, we're gonna be doing this exact same thing, but in Godot, okay? So let's go back over here and start analyzing our current scene. So what we have here are 3 different obstacles, and right now they share the exact same behaviors. They all share this obstacle script, okay? And what this does is that it connects its onBody enter signal to this function, and if it is colliding with the player, basically the game is over. So until here, you may not see many things that are not correct, but there are actually lots of them. So first of all, they are 3 completely independent scenes, but in reality, they share a lot. As you can see, they share the same script, they share the fact that they all have a collision shape and a model, basically. and they all share the same script. So let's say that then I also want to add to all of my enemies a certain particle. So let's say a particle, I don't know, just as a decoration or for when the player collides with them. Okay, so let's add a GPU particles, for example. And let's say that, well, we have set it up, everything. But what happens is that we would have to go to each of them and paste them. Okay? Okay? So it's not, as you can see, efficient. So how exactly can you do this? You can do this with inherited scenes. And inherited scenes are pretty related to inheritance itself and to abstract classes. Okay? So we're gonna see all this. First of all, whenever we are thinking about all this, we have to look for the similarities. Okay? So in this case, we are always using an area 2D as the parent of everything, as the root, then a collision, and then a certain model. Okay, so having all this into account, what we need to do in order to get rid of all of these problems is to create a new scene. Okay, and in this case, I will just copy, okay, one of these scenes. So I'll just press Ctrl C and select them all, and here I will paste them, and I will delete these particles. And I have a pretty similar scene, but instead of calling it so, I will call this one obstacle. Okay, and I'm gonna save it, okay, in my scenes folder. So obstacle, right over there. Okay, now what I'm gonna do with it is go into scene, and over here I have a new button to create a new inherited scene. Now I already have here an obstacles folder with my different obstacles, but these are not inherited scenes. So I will create a new folder in this case. Sorry, where is the new folder button? I don't know where it is right now in this version. But anyway, let's create it over here. And I'm gonna call it inherited obstacles. Of course, you can call this whatever you want. In reality, if I didn't have this folder, I would just call it obstacles. Okay, but let's create it once again. Inherited scenes, inherited obstacles. And here how to give it a name. So in this case, let's take a look at what we have. So we have a saw scene. So let's create it right over here. And I don't know why I am not able to do it. So new inherited scenes. I don't know why it's telling me. Oh, but I have to firstly select it. They have changed this logic in this new version, I think. So anyway, let's go to the obstacle scene. That is right, this one. So we have to open it up. And now we have to save it. Okay, it's pretty different, I believe, the workflow. But anyway, and in this case, let's call it saw. Okay, so as you can see now, it is inherited obstacles saw. And now we can modify it and just call it saw. Okay, so we have a base obstacle class. In reality, not a class right now, but just a scene. And this one is inheriting from here. You can see that also these nodes are basically yellow right now. And for example, if I wanted to delete this one, you can't. Okay, you can't operate on this node. Okay, so what you can do is, for example, modify this shape. So if you wanted to create a new box shape, you would be able to do it. And if you save the changes, it shouldn't take also place in the base scene. As you can see, they are unique. Okay, and if they for some reason do take effect, just make sure that this shape is unique. So make it unique and do it again. So now you can start to see. Okay, now let's say that also in our obstacle, once again, we did want to have particles or whatever it is, and we save it. And in our new scene, we now have the particle. So you can start to see the huge advantage of this. So now that we do have this, okay, we can start to think better, okay, on how exactly we're gonna be doing. So as we have seen, they have all different models, okay? This one has this model, this one has this model. So there is not much that we can actually do with these models. I mean, we can add nodes to them if we want, but we cannot modify. Let's say that this is not the saw and this is the spike block wide. So I cannot kind of directly modify this model because, as you can see, we cannot delete it. So there are many solutions. Different people will tell you different solutions for this. But I believe that what we can directly do is here in the obstacle, rather than creating here the model directly, what I'm going to do is to delete it, and with Ctrl A, I select here to add a new node, and I will add a new node 3D, and I will just call it model. Okay. So now when I save it and come back over here, I have this model node over here. So here I basically have to put the corresponding model. So once again, let's try to find here in the models folder the saw that I want. Once again, in the saw sim, so models, and let's look for saw. Okay, this one, and I will drop it over there. So now I have it, and once again, it's not gonna take effect on the base class. Okay, but I do have like the indicator that we should have the model. Okay, and once again, here I can override this collision shape and do whatever I want. So if as you can see here, I had this button to discard the changes. So if I do it, it comes back to the original shape that has here the original model. In reality, by default, the collision shape should be completely empty, I believe. And then in the different models, in the different obstacles, actually, we're gonna be modifying this. So over here, we have the collision shape. We actually have this button to quick load the collision shape if you already have one created, but I don't think that's gonna be the case. We should also, over here in the collision shape, at least, okay, but yeah, this is moved. I don't know if I have moved it or wherever, so this should be in 0, 0. And here I just create a new shape. For this shape in specific, probably maybe a sphere is gonna be just fine. So something like that, it's gonna be perfect. And now we do have our saw. Once again, remember the advantages. Whatever change we do to this is gonna take effect in all of them. Let's say that now, for example, we want to make the model much bigger in all of our scenes. So we just make this 5, for example. We save the changes, and now this is gonna be massive, basically. Okay, so you can start to see the real advantage of this. So this is for the saw. I'm gonna do with you the other 2 obstacles just in case, just to make sure that everything's clear. So in reality, another way of creating inherited scenes, because the previous one, I don't know if the flow was modified or whatever, I don't really remember. But anyway, I will go to the obstacle scene, and I will right click on it, create new, and here, new inherited scene, sorry, my bad. There it is. Once again, I will rename it. In this case, it's gonna be spikes, for example, which is this one over here. And let me check the model. So it is this one, trap spikes large 2. Let me save this one in inherited obstacles. And let's look for the name of the spikes. Oh, I've closed the sim. My bad. So let's look for it here. So this is gonna be models. And if these are my spikes, objects, and spike block, trap spikes large, this one. Okay, I'm gonna drag it over there. Also make sure that these are all in 0, 0, because if not, they're gonna be having problems. But anyway, for these spikes, now the collision shape is gonna be different. I believe that with the box shape is gonna be the best thing to do. So let's just make sure to make this a little bit smaller, something like this. Once again, it doesn't have to be 100% perfect, like this, and also something like that. Okay, and here a little bit smaller. So yeah, something like that. I believe does look good. Then if we have to adjust it, we're gonna do it. You have seen that it's pretty simple. So now you can start to see all this power. Once again, we now have these 2 obstacles, but then if we want to do any modification to all of the obstacles, we don't have to be copying and pasting data. We just have to do it in the base obstacle. In reality, instead of just calling it obstacle, what we can do is call it exactly that, base obstacle, because I think it's clearer. So here in scenes obstacle, I will call it base obstacle, and I will put inside of my obstacles folder. Okay, so now I have, sorry, in my inherited obstacles. Okay, there we have it. Okay, so once again, remember that, I don't know, if then, what could we add here? I don't know, an animation player to play some kind of animation, even a twin or whatever it is. We save the change over here, and it takes place in every single obstacle. Okay, so this is the power of this. So let me just create the final obstacle, okay, so that we make sure that we are on the same page. So right here, new inherited scene. Let me check the name of the other one. It was spikes blocks wide, I believe. Yes. So let me copy this one, and let me open up the previous one. So inherited, base obstacle, and let's create a new inherited scene. Let me paste the name over there. I will save it, inherited obstacles. That sounds good. And now this one I can delete it. And I want the base obstacle class. Because I had an animator over there that shouldn't be here because I have not saved the changes, as you can see. So I saved the changes and now it's gone. Okay. So we have to do something very similar. I believe that I can directly press on instantiate, and here I should be able to look for it. So spike block wide.tscn models, this one. There we go. Once again, we make sure that everything is in 0, 0, that it should be, so perfect. And now what we can do is to grab here the collision shape and once again create a new one. So maybe a capsule, and here also we can rotate it. So the axis is the Z, yes. So 90 degrees. Okay, and we also have to move it up a little bit. And let's make it a little bit bigger, something like that. Yeah, something like that looks perfect. And once again, take a look at how all of them have different collisions because we have done an override, basically. We have overridden some data. They also have different models, but they still inherit from obstacles, so any modification is gonna take place in all of them. So with this, we have already seen one advantage. This is just one of the all the advantages that inheritance has. So we're talking about inherited scenes, but there is way more things that we can talk about. So one of these things that we can talk about is now in scripting, okay? Now, as I already mentioned, all of them do share the same script, so they're gonna have the exact same behavior. So I will go to the main scene, okay? And, well, I'm using here the previous obstacles. These are not the inherited obstacles. So what I'm just gonna be doing, or here I will just hide these ones, okay, and I will create a new container. So I'll create a new node 3D, and I'll call it inherited obstacles container. I know it's pretty long, but anyway. And we can go ahead and instantiate these different obstacles, okay? So let's grab here a saw, a spike, and a spike block wide, basically. Okay, so now we have everything. And I'm just gonna position some of them. For specific, we already have a tutorial in the channel, okay, with how to position these objects perfectly in a 3D space, but it's basically using snapping, at least for this. So let me grab here the saw, let me move it up, and maybe position it over there. As you can see, it's in the exact center. And let me also grab these spikes. And with these spikes, I think I will have to modify the snap, because it's not gonna snap exactly where I want it to be. No, it isn't, so I have to go to transform, configure snap, and the translate, let's put it at 0.25, I think it's gonna be. Yeah, perfect. There we go. So something like that is gonna be good. And lastly, with the spikes block wide, let's put it right over here. So now we have all our scenes set up with the corresponding obstacles. So once again, here just do create your own test scene for this. Now, as you can see, this script does has some options that would allow us to kind of modify the behavior. If we take a look at the script, what is happening? Okay, yes, in the ready, they all connect to the body enter signal, and basically here, when we collide with any of these obstacles, the game is over. But also here, what happens is that we have a process delta function, which if this can rotate variable is true, it's gonna basically rotate the object in the z-axis. What this is gonna do, for example, in the case of the saw, is this, okay? It's gonna be doing that. So that is good, okay? But for example, the spikes, we don't want them to be rotating like that. It doesn't make any sense, okay? So that's why I've created here a variable that is an exported variable that allows me to set this dynamically. So you can see that the saw has this, the spikes shouldn't have it. So let me go to the spikes, but the one that is from inherited obstacles, and let me disable this, okay? So now when I press play, I should have the exact same results as we used to have. As you can see, these two rotate, but the spikes, these spikes over there do not. So that's what we have right now. So this is not bad. This is perfectly valid. Okay. So for these kind of things, it is in reality what we needed to do. So that's perfectly valid. But this is not gonna allow us to do different things based on what happens when we collide with these obstacles. So once again, remember, it doesn't matter if I collide with this saw, with these small spikes, or with this one big spike, I always lose. But what happens if over here, okay, I want to have modification? So if I collide with the spikes, for example, I just lose 1 life, okay, whereas this one directly kills me, okay? So how could we do it exactly? And here is where we can be talking about inheritance in scripts. We have already covered inheritance in scenes, but now we're going to be talking about inheritance in scripts. And this is also where we're going to be talking about abstract classes and how they can be interesting to use. But of course, why didn't you start talking about abstract classes at the very beginning of the video? Because in order for you to understand abstract classes, you have to understand scene inheritance and script inheritance. If you don't understand those two things, you can't understand abstract, okay? So now that you do understand these things, we can move over to the abstract classes. Or, well, not directly abstract classes, we have to talk about scripts inheritance. So remember, we have our base obstacle, this has our obstacle script. In reality, let's rename this script to base obstacle, okay, so that it is clearer. So over here, rename base obstacle. I like to call these things base because if not obstacle, it's not clear that this is a script that then is gonna be inherited, okay, or extended. Actually, will be in Godot. And the same thing with the scenes, as we have done that our obstacle base class, we have called it base obstacle, okay? So I don't want to get too technical, but maybe you have read this line and you haven't understood what it does, and here's gonna be super important for you to understand what this is doing. In order to understand this, what I want to do is to just create a brand new 3D scene. Okay, and I'm just gonna be creating a character body. What a character, or actually maybe with the player I can do it. Yes. So for example, the player extends from character body. Why from character body? Because it is attached to a character body 3D node. Okay, that's clear. That's something that probably you already know. Here with the coin, this inherits from an area 3D because the script is attached to an area 3D node. The same thing with these obstacles. They all extend area 3D because they are attached to an area 3D. That's not something new. What is maybe new or something that is not perfectly clear, and it is important for you to understand this in order to understand script inheritance, is that when you have this extends something keyword, what is telling Godot is that there are some codes, some variables, some functions that you are able to use because you are extending this. For example, with the character body, it's a perfect example. You move differently an area than a character body, because the character body, what you have here is the velocity, okay? And when you take a look at the velocity, okay, what happens is that it is a property of character body 3D dot velocity, okay? So it is something that only exists in the character body 3D class, okay? That is called a class, basically. I don't really know if this is also called a class in Godot or it has a different name, but in general programming, this is called a class. So we are able to access this velocity variable because you are extending from character body 3D. If we try to access this velocity in other scripts that doesn't inherit character body 3D, in this case, for example, it inherits area 3D, and if we try to, in the process or wherever, to call velocity, as you can see, Godot doesn't tell us you have a velocity. It doesn't. It's gonna be telling us identifier velocity not declared in the current scope. What does it mean in the current scope? That there is no velocity declared in this script itself, and there's no velocity in the base class, basically in the area 3D class. If you press Ctrl and then click on area 3D, for example, you have a description of this class. Exactly, it's called class, so perfect. And you have all the properties that this has. Okay, and methods and lots of things, okay? So as you can see here in the properties, you don't find a velocity value, okay? You don't find it. But in the player, or well, in the character body, control plus click, you are gonna be finding a velocity over here. So this is for you to understand the basics of script inheritance. When you have this extends, it's basically telling Godot, okay, I have some variables and also functions, but in most cases, you just use just variables, values, as we have seen velocity. So I have some specific functions that you can use, okay? Now that you understand at least a little bit this topic, we can now move on to script inheritance, okay? So as we have done before, what we actually want to do is to have a base obstacle, okay, script as we now have. And then each of these obstacles are gonna be able to override these behaviors, okay? We're gonna be having similar or exactly the same behaviors in some cases, and in some other ones, different behaviors. So, for example, what happens? We want all of our obstacles, okay, to be able to detect collision with the player, okay, but we want them to do, let's call this one same and this one different. So they are gonna be having actually similarities, differences. So in terms of similarities, yes, they are all gonna be detecting collisions with the player, but the difference is that they will do different things. So if we collide with obstacle A, it's gonna decrease 1 life. The other one is gonna directly kill the player, and the other one is gonna do something else. Okay, so that's the magic of this. So of course, here you could have an endless list of things. Remember the Unity example? There we had lots of usages that I didn't want you to confuse you with, but this is for you to understand. So here you have the base obstacle, okay? So once again, this can rotate is okay, right? Like this, you don't really have to do anything with this. So I will start with something very basic. I will just print different messages depending on which obstacle you are colliding with. Once again, previously, what maybe you used to do is to, okay, all of them share the same script, remember? So here, what you do is maybe, okay, check for the name. So if this was name, right? Yes, name equals, in this case for the saw, you would do print colliding with a saw. If the name was spikes, print colliding with spikes, or whatever it is. Once again, this is, if you are a complete beginner, this is not bad, but there are way better ways to do it. So once that we understand all this, let's start. So we have this base obstacle script, okay? And first of all, let's start creating the different scripts that are gonna be inheriting from these ones. Once again, it is probable that you're gonna be having one script per each different type of obstacle in this case. So here in the base obstacle script, let's create a new folder. Obstacle. Here I was also testing out some stuff with abstract that we don't need that folder. So obstacles, and here with base obstacle, I believe there is not like here a button to directly kind of inherit from this one, but anyway, we can right click on the obstacle script, create a new script, and make it here where it says inherits, okay? We're gonna type in base obstacle, okay? As you can see here, it tells us invalid inherited parent name or path. So in reality, what you have to do here with this button, you can inherit from an object, basically from different things. So for example, nodes, okay? Or with this one, you can inherit from a file. So in this case, let's just inherit from a file. I will show you something in a second, because when we create the script, well, it is good, but the extents is like super long and it is not clean. So in reality, what is usually done over here to avoid this is to directly declare a class name over here in the base obstacle. So you can just call it base obstacle. Let me delete this script and let me now create a new one. Script. And now when you select here inherits, In reality, when you press over here, you should be able to look for base obstacle, I believe. No, we are not able, but I believe it's because I have not saved the changes in the script. So scripts, inherits from base obstacle. As you can see, class base obstacle. So let's just select it over there, or you can just type in the name, but well, I just wanted to show you that. And for the path, yes, let's save it there, but let's make this a script for the saw. Okay, so there you have it. Now this extends from base obstacle. So for example, let's do something pretty simple. First of all, once again, let me just create these scripts for all of the obstacles. So I will press Ctrl D to duplicate it, and I will do it for the rest. So this is gonna be spikes, and another one for my spike block wide, and I will go ahead and attach them. So right now in our base obstacle, so base obstacle, I believe there was a shortcut, right, to kind of Control Shift P. Nope, there was a shortcut to quickly take a look at the scenes, but anyway, with Control P you can still do it. So we have the base obstacle over here, and in reality here let's detach, okay, detach the script from here, okay, and directly let's save the changes. And so all of them should have lost the scripts right now, but these are not, as you can see, the inherited ones. So let's make sure that firstly I will close these scenes because it's pretty confusing if not. So let's close all of them. And there, well, there I just close them, but it's the same. So spikes and spike block wide. So now as you can see, all of them have lost their scripts, but now we can attach the corresponding ones. So here we are in the saw. So let's go to the inherited obstacles, but in the scripts, obstacles, saw, and let's load it in. Now spikes. Let's look for the script, obstacle, spikes, load. Spike block wide, and let's do the same thing. So scripts, obstacles, spike block wide. Okay, so let's start with something very simple. In reality, you can leave attached here the base obstacle if you want, but I don't think you're gonna be taking advantage of that. So let me just go to look for the base obstacle, and let's do something very simple. As soon as the game starts, I want to print a different message in each class, okay? So first of all, we should use the ready function, right? So yes, that's correct. But we're gonna see something interesting here. First of all, I will just print. So I am in the saw script. So I will just print saw in this case. In this one, I will do the same thing. So, sorry, not saw. This one are the spikes, as you can see over here. And lastly, let me copy and paste this. This one is spike block wide. Okay. So now when we play, let me show you here the output. When I press play, I do have the corresponding messages. So everything's working fine. However, right now if we collide with them, well, first of all, we have this thing of the can rotate, but that's something different that I have not set up the variable correspondingly. But if I collide with them, I am still basically losing over here, as you can see. So that's correct, because what is happening is that in the background, the base obstacle ready is also being executed. So we are also executing this, and also at the same time we are executing whatever we have over here, because in reality we have kind of two ready variables, okay, in reality. And let's do another test, okay? What happens if here we create a variable? Let's just call it counter. And in ready, let's make counter plus equals 1, okay? And then in each of my classes, just in one, print counter. First of all, let me save the changes so that I do get auto completion here. So there I got it, counter. And now here we can also see what we have seen in the character body. Here we see no counter value, but in reality this counter value comes from this base class, okay? So That's basically what we have. And now when we print this, as you can see, we do have it over here. We have everything that we should have, and also we have a 0 over there. So what is in reality going on over here? Because my counter was 0, but then I've told here Godot to make my counter be increased. So in reality, what you have to do in these cases, and what is the best practice, is to always call super over here. So with this, what you are telling Godot is, okay, firstly, call the base class ready, and then do whatever I need to do. Basically, this base class that I'm calling this base class is also called super class, but I don't think that's a clear keyword. Super, I don't know what super is, Superman or whatever it is. I don't think it's a proper term. I know, me personally, I prefer much more base class. It is way easier to understand what that class is. But anyway, so now let's do the same thing. Let's just execute super, okay, and then we print the corresponding thing that we want. So now, as you can see, we still get 0. So why is that? So sorry, here in reality I was just mixing up classes. So in the same one that we are calling super, here how to print it, I was calling super in other one and calling print counter in other one. I believe that was the problem basically. So in this one we first execute super, which basically is gonna go to a base obstacle and call this. Okay, it's basically as if we had this. So let me copy this code and go back to here, spike block wide. This is equal, okay, to this, okay, basically, just for you to understand. Now here I am having, well, I am not now having any problem here, so there you have it. Okay, it's basically what is going on. Okay, so what you can also see over here is that, let me delete all this, and let's print counter on a class that is not calling super, okay. So let me just print here counter. So in this one, I'm just telling it, okay, on ready, print counter. Let me call it now here, and now counter is gonna be 0. Why is that? Because what we are doing here is overriding this ready function. So if we don't call super over here, what it's gonna go to doing is create a new method. So it's not gonna be caring about what used to be in the ready function. If we don't call super, it's just, okay, declaring it from scratch. Whereas if we call super, what we're doing here is, okay, also not only do extra things, okay, sorry, not only do what ready is supposed to do in our base obstacle, which is basically this, but also do something else, in this case, printing counter. So this is super important, because what we are actually doing here, and in Godot is not clear, and maybe they do fix it, is that what we are doing here is overriding a function. Once again, in C#, it is way clearer. Okay, let me actually show you this. Because, for example, in C#, once that you are overriding a function, do not pay attention to any of the rest of the code. If you don't understand Unity C#, it doesn't matter. You have another keyword here that is to override a function. And here you don't have super to call the super class function. You have base dot the name of the function. So in this case, what I'm basically doing for different reasons is, okay, on the start, which is basically the equivalent to ready in Godot, I am getting the player game object with a tag, which is the equivalent to groups in Godot. And after doing that, once again, for different reasons, I am calling the base dot start, which if I go to, basically does all this, okay? So it is the same, but it's not pretty clear what Godot is doing if we don't have the override keyword over there, at least for me, okay? So here what we are doing is exactly that. We are doing, let's say, func override, okay? It's what we are doing, basically, but of course this is not gonna work. But just for you to understand what is going on. So remember, whenever you are overriding a function in Godot, okay, what is gonna be happening is that all of its behavior, unless you call super, is gonna be completely deleted, and you're gonna be writing its function, the function of the function, okay, or the logic of the function from scratch. This can be useful in some cases, and in some other cases, okay, it's not useful. So that's something that you do have to understand. And now that we have understood this, let's do a more practical example. So we are detecting here the collision, but once again, what we want to do really depends, okay? So what I'm gonna be doing is two different things, okay? So we have three obstacle. So here in the base obstacle, I'm gonna put some comments just to know what I'm gonna be doing. So if I collide with the spikes, I want to lose, or actually I'm gonna do it decrease lives, okay? And after that, check game over if I don't have any more. Now for the saw, what I want to do is to, for example, decrease 1.5 lives, and here 1 life. Let's do it something like that, okay? And here once again, I want to check for the game over. And now for the biggest one, which is spike block wide, I want to directly make the game end, so game over. So taking all this into account, we can start to apply everything that we have learned and start doing something. So what we're gonna be doing is to create some functions, okay? Usually functions that you can override are prefixed with an underscore, such as here on body entered or whatever it is. So I'm gonna call it this one game over, okay? Because in lots of cases we want to execute the game over. So game over, and this is basically the game over logic in this case, in the case of my game. Pretty simple, right? So here I will just write pass momentaneously. So this is done, but I also have to decrease lives, okay? So it shouldn't be done in the base obstacle, it should be done in the player. So let me do it like in a way that maybe it's not the best way of doing it, but anyway, this is just for an example, okay? So I will just create a new variable over here, lives, which are gonna be, actually let's make it a float, so 3 lives. Okay, so then we need another function that is also gonna take a parameter to define how many lives we want to lose. So decrease lives, and I'm gonna ask here to provide lives to remove, okay? There we go. Okay. And now we need to do the logic. So we have to decrease the lives. Okay, so we have to look for the player. So I believe that the player used to have a group. I believe it should be part of a group. Yes. So let's copy the group name and let's just find it using that. So as the same way in which I have found the canvas layer, but in this case it's gonna be bar player node 3d equals to get tree dot get first node in group player, and then I'm gonna do player dot lives minus equal lives to remove. Okay, basically that. Then after doing that, I have to check for the game over. So if player dot lives is equal or smaller than 0, I will call game over. Okay, in reality I won't override game over, so it should be called like this without the underscore. And I don't really remember how to order this code properly, but there is an official GDScript style guide, but I don't want to go back to it and order the code perfectly. It's not the point of this. But this one that is overridden, yes, this one is okay here, I believe. Yeah. So now what happens is that, okay, if we have collided with a player, we want to do different things. So in reality, once again, here the decreased lives is not what I wanted to override. I want to override another thing. I will show you why and what in a second. So in reality, here I will create the function to override that this is collided with player. This is gonna be with an underscore because it's gonna be overridden. So collided with player, I will just make it an empty function, and over here I'm gonna call it. So by default, nothing is gonna be Done. We have to override this function and do whatever we need to do. Sometimes it's gonna be directly losing, as in the case of the spike block wide. In other cases, it's gonna be decreasing a certain number of lives, okay? And after that, checking for the game over, which is in reality done automatically. So let's do this, which is pretty simple. We have to go to the saw, okay? For example, and let's delete this. And to override function, remember, we just call here underscore collided. We have to save the changes firstly. Sorry, it wasn't with the underscore. Yes, it should be with the underscore. If it's not with underscore, it's not correct. Collided with player, here it is. Sometimes auto completion does not work, but it should be just fine with this. So once again, let's remember what we have. So in the saw, it was decrease 1.5 lives. So it should be decrease lives 1.5. Okay. Lives to remove was an integer, but this is not correct. This should be a float. This is just an error of the function itself, but not inheritance. There we go. And when we save the changes, yes, that warning is gone. Let's copy this and paste it over here. By the way, all this copying and pasting, then you're gonna see what could be done with abstract, okay? So let's continue with the next one. So the saw is done. Then we have the spikes. So we want to decrease just one life. And in the case of the spike block light, it was directly game over. Okay. So now you can see how we have different behavior. So when this one collides with the player, we decrease 1.5. When this one collides with the player, 1. When this one collides, directly game over. I know you may think, oh, but if these ones just decrease different number of lives, you could have created an exported variable, lives to decrease, or whatever it is, and then set in the inspector. Yes, correct. I am just giving you an example to do it with inheritance, because you will see them. You are actually seeing the many advantages that this has. This is a pretty simple example, but in reality, in your everyday life, you're gonna be seeing even more advantages that this has. Okay, but just for you to know that. So with this also, what I forgot to say is that whenever we have decreased the lives, we should also print player.lives. Okay, and also as soon as the game starts, just in case, in the ready of the player, let me print lives, just so that we can actually see how many we have left. So let me move this over here. So initially we have 3.0. This is correct. So let me remember. Oh, we also have this thing of the rotate, but that is because we attached a new script. So here in spikes, we disable can rotate. Why do we have this can rotate over here when we don't have a variable here? Because it is inheriting from base obstacle, and this base obstacle is the one that has the export variable over here. Okay. So let's click play. So we have it 3.0. So let's remember the saw was 1.5. Oops. So if I collide with the saw, I should have 1.5 lives left. So let's try to do it. Okay, there I have it, 1.5. Then I've lost here because I reached like the death zone, but that's something different. So let me clean the console. We used to have 3 once again. And now let's collide with the spikes. So we have now 2 lives left. Okay, if I collide again, I have 1 life left, 1 life in this case. And if I collide again, it's over. Okay, let's try to collide with this and reach the platform. There I've got it. So now I have 0.5 because I've collided with the spike, which is 1, and the saw is 1.5. So it's correct that I have only 0.5 lives left. So now I can collide with whatever I want. In this case, well, the lives are negative, but that's not a problem in this case. Okay, and well, the game is over. And now if I directly collide with this guy over here, okay, my lives are still 3, but as I have told it over here to just make it game over, sorry, the game is over. Once again, here you could say, okay, let's just call here decrease lives 3, okay, and with that it's gonna be done. Yes, you could do it perfectly fine, but once again, this is just a pretty simple example on how you do it. Once you understand the logic, and if you were actually able to understand this video, you can see the true power of this. Of course, you could directly, once again, call here decrease lives, 3, and that's all. And as you are just calling this method over here in the base obstacle, whenever you collide with it, you can just call decrease lives. And here have an export variable to determine how many lives you're gonna decrease in each obstacle, and then set it individually in each obstacle, as we have done with gun rotate. But once again, that is one way to do it. It wouldn't be bad, but I wanted to teach you basically inheritance. Okay, so this is not a good example. I just wanted to give it to you for you to learn. Okay, I don't want to say that it is not a good example. I just wanted to say that that is also another possible way to avoid using inheritance, but you have seen the true power of this. Okay, and it's for more advanced projects. Yes, it is. So now we have went through scene inheritance, script inheritance, and now we have abstract classes. Okay, so you have seen something that we have done before, that was copying and pasting the functions that we wanted to override. Okay, and that is something that in languages such as C# you can avoid doing. Let me show you this with abstract classes. Okay, so let me look for some kind of abstract class that I may have over here. So I believe the character flip is an abstract class. Yes. So yes, here we have it. Okay, so let me look for maybe a class that is maybe easier to understand. But yes, all of them are gonna be maybe complicated. Yes, but anyway, do not. It's gonna be a little bit abstract, not abstract in abstract to actually imagine what is going on. It doesn't really matter. Okay, I just want you to understand something. So let me go to this method, to character movement. So as you can see, this has a protected. It doesn't matter what protected is in this case. What matters is that this is an abstract function that is void. This is the same thing that we have in Godot, that we have this. Okay, it basically means that this function returns nothing. And this set direction is always called in the update. So all the time, in order for the character to be able to move, it's calculating the direction. Now, what happens? The enemy movement calculates the direction differently, because the enemy wants to move towards the player, basically. This here is telling Unity to move the enemy, okay, towards the player. Okay, basically that. But what happens in the player? If I go to a player movement class and I go to set direction, in this case, direction is going to be equal to movement, which is basically a variable here that reads the input. Okay, so it's pretty different. We still use the direction, but how it's calculated is different. So once again, it's something similar to what we have already done. So where is the true power of all this? Once again, here we have the class player movement. And this thing over here is telling that it extends character movement, or it inherits from character movement, just for you to understand that. So what happens is that, let's say that we have a brand new script that we wanted to inherit from character movement. Okay, so I'm gonna create a new script over here. Let me call it test movement, for example. It doesn't matter the name. .cs. And I'm just gonna type here mono behavior to start off a new script. Once again, there are lots of things that you're not gonna be seeing right here, but it doesn't really matter. I'm not gonna get auto completion because I don't have the project open, but once again, it's not a problem. I'm having here to do character movement. Okay, and yes, I will need code auto completion. So let me open up Unity. So now that I have Unity opened, as you can see, I have an error here. It tells me test movement that not implement inherited abstract member. Member is also a synonym for class. So does not implement inherited abstract member. Character movement.set direction. So remember that our character movement script has an abstract method, which is set direction. What abstract means is that every single class that inherits from, in this case, character movement, must override this method. Why is this useful? Because in Visual Studio Code, what you can do is to press Ctrl period, or I believe with right click you can also do it, and there was another button here to do it, I believe, but well, I can't find it. I always use Control, or here, this light bubble, yes, here, and you can click implement abstract class. So you automatically have the method directly copied and pasted for you. Okay, so this is one of the main advantages of abstract classes, that not only, as you can see in Godot, we have not made the class abstract. It's just a class that we are inheriting. But the advantage of this, one of the advantages of abstract classes, at least in Unity and C#, is that you can get to override the methods, and Unity will directly copy and paste the method for you, and you can directly write your implementation here. Okay, so you don't have to be copying and pasting data. Once again, you think, oh, but there's no problem just copying and pasting functions. Of course, but once again, these are tools that are meant to make the development flow way better, okay? So all this really helps. Also, another thing that you have to understand about abstract, I'm saying here in Unity because the system is a little bit clearer. We have made our character movement class abstract. So what happens is, if I wanted to instantiate this class, so let me look for character movement. So if I wanted to put it in any node, which would be equivalent to game objects in Unity, can't add the script component character movement because the script class cannot be found. Well, I have a compile error here, so yes, because I have this. Yes, but it should be fine. Let me compile again. Yes, let's give it a second. So let's do it again. So character movement. Another advantage of abstract classes, besides what we have seen of quickly being able to override methods. So if I want to drop it in any place, can't add script behavior character movement, the script class can't be abstract, okay? So it's just a security measure because these classes are not meant to be directly instantiated, okay? Or put in any game object. So it's just a security measure that is used. We are not using character movement in this game. We are actually using player movement, which extends character movement, but it's not the class itself character movement, and also in enemy movement. Okay, once again, this is just a security measure. So yes, those are the two advantages of abstract classes. So now here, what I want to show here, I was checking this thing of the super because it was a little bit confusing at first. So how we create an abstract class in Godot, basically with this keyword combination. So let's copy it directly, and in our this is gonna go to our base class. So let's paste this over here, and well, for the class name we have already defined it as base obstacle, and it extends area 3D. Okay, so this is how you quickly replace everything. So like this, you're not gonna be having any difference right now. What we should have, if we save the changes, is that if we try to attach this script to the base obstacle or to whatever it is, we should have an error. And by the way, let's rename this to base obstacle. Okay, so if we go to scripts obstacle, we have base obstacle. We shouldn't be able to put this over here. Here we have it. Cannot set object script, and well, the script path should not be abstract. So the same thing that we used to have in Unity. It's just a security measure. Of course, we can still attach the different scripts, basically. Oh, here, I don't know why this was deleted. Base obstacle, okay? So once again, if we try to untouch this says spikes, we can still attach it. Why? Because it extends base obstacle, but it is not a base obstacle, okay? It is an instance of base obstacle, let's say, okay? It's not the same. So that is basically all that was implemented right now in Godot in terms of abstract classes. You don't have, unfortunately, abstract methods. So if you actually go to the GitHub pull request, the pull request is basically the change itself that was implemented. For example, here you cannot also kind of create it as a new class, but well, this is something that it's even more advanced to what we have already covered, but it's not really necessary. So here we have a comment that is pretty interesting. So here, in terms of, there won't be virtual and override. Once again, coming back to Unity, override, we have already talked about, basically overriding the function. But in order to, at least in Unity, to define that a function can be overridden, it's basically to define it as virtual, okay? So well, for example, here we have a protected virtual fixed update. So this is a keyword that will tell the engine, okay, this function can be overridden, okay, but it's not mandatory, okay? As you can see, we are here, this is character movement. In our test movement, we are not overriding any of the virtual functions such as updates, fixed updates, and everything compiles well. If I make any of these functions abstract, okay, well, in reality, abstract functions cannot also have a definition. So let's delete everything. Okay. And now, well, I'm also having lots of problems here. I have to implement the class again, and I do have to give it a behavior, basically, okay? So that's basically what you have to understand with that comment of virtual and override, that right now they are not implemented inside of Godot. So the only implementation that we have right now is just the abstract class itself, okay? That's maybe gonna be done in a future pull request. Basically, there's some work that is being done right now, but well, because in reality, the true power of abstract classes is this one that I have already told you right now, I believe. That is basically having abstract functions that you can quickly implement and modify its behaviors in the different scripts, and you don't have to be copying and pasting data, okay? But well, the good part is that you already know everything, mostly everything about inheritance, about scene inheritance, script inheritance, even everything about abstract classes. So whenever this is released, because probably it's gonna be released very soon, you're gonna be able to take advantage of it right away. So once again, remember, virtual functions are the ones that you can indeed override if you want. So in our test, this one was fixed updates, was it? Fixed updates. So what you can do is, once again, protected, I don't cover it here, it doesn't matter. We can do override, void, and here we also have the option, so fixed update, okay? And here we have it, okay? And we can do whatever we want to do over here, okay? By the way, fixed update is just physics process of Unity, okay? Whereas if you create an abstract function, or what it's telling Godot, Unity, is that any class that inherits from character movement must implement the abstract class function, okay? So you don't have to be copying and pasting data. That is the main advantage, I believe, and the other one is just that this character movement class cannot be instantiated. It cannot be attached to a node, okay? So once again, I hope that you were able to learn lots of things here, and that now whenever Godot does release abstract functions and even extra stuff with it, you can take advantage of all these amazing features. So I will see you in the next one, and bye bye. And if you want to continue learning, if you liked my explanations, okay, you have my own Godot and Unity courses in the description down below. As you can see, the original price are, for example, this one $20 and this one $45, because this course is something like 22 hours long. But using the coupon code in the description down below, and if you are fast enough, you're gonna be having a huge discount, as you can see, and you're gonna be having everything for just $10. I have this Godot course, this Unity course, in which we cover literally everything, and this is even my newest Godot course, okay, which, as you can see, was published just a couple of weeks ago. It has over 11 hours of content, and we don't cover inheritance because it was way too advanced, okay? But you do learn how to create the 3D game that we have used as an example, and of course 2 other complete games. So once again, all these links are in the description down below.